1.
Hey guys, I'm back again. We're going to do a flipped classroom again. Today we're going to talk about something called the correlation coefficient. We've already spoken about the different types of correlations that exist in a scatter plot, but today we're going to go a little further, and instead of just using words to describe the correlation, we're going to give it a number. So as we've discovered, scatter plots have 5 different types of correlations, and I'd like to go over those a little bit again. We have a strong or weak positive correlation. We had a strong weak negative correlation, or we had no correlation at all in a scatter plot. If you don't remember what those words mean, let's kind of assign them to different scatter plots just to remind ourselves what they mean. The first one, though, we didn't talk about previously, is something called a perfect positive correlation. It's a scatter plot where the points are so close together that it's evident they form a line and they're close together going in a positive direction. We have a strong positive correlation where the scatter plot, the points are close together, still going in a positive correlation, but positive direction, but they're not perfect in a line. And then we have our weak correlation where the points are more scattered and they're still in a visible positive direction. On the flip side, we have a perfect negative correlation where the points go in a perfect line in a negative slope or a decreasing fashion. We have our strong negative correlation where the points are more scattered, but they are tight together in a negative direction, and a weak negative correlation where the points are obviously going in a negative direction, but they're way more spread out. Lastly, we have our correlation or our scatter plot that has no correlation at all. These points, if you look at them, you could see that there's no direction that we can tell of in the scatter plot. So we consider this having no correlation at all. Today, instead of using words to describe the correlation within a scatter plot, we are going to assign a specific number within a range of numbers to describe the correlations. This is something we call a correlation coefficient, and we represent it with the letter R. So we might say R equals -1 or R equals 0.25. We're going to give it a letter and a specific number to represent it. The correlation coefficients are taken from a scale from -1 to 1 with different ranges of numbers to describe these different correlations. Today we're going to look at the specific range of numbers that represent all the different types of correlations. So I want you to take out your packet and look at the front, and we're going to look at these a little bit more in depth. So we're going to look at the first part. A correlation coefficient, or R, is a number that quantifies a type of correlation that exists in a scatter plot. It ranges from -1 to 1. The closer the points are to forming a line, which is what we call a strong correlation, the closer the correlation coefficient is to -1 or 1. If it's a -1, it means it's going in a negative direction. If it's a +1, it means it's going in a positive direction. So we're going to look at the first one. Since that particular scatter plot is going in a negative direction and it's in a perfect line, we're going to give this scatter plot a correlation coefficient of -1. Now, the more the points are on a scatter plot, the closer the correlation is to 0. So that would mean no correlation at all. So if we look at the other scatter plot, if you look at those points, there is no direction that's discernible. So we would give this scatter plot an R, or a correlation coefficient of 0. What we're going to do next is we're going to estimate correlation coefficients for the following scatter plots. But first we have to come up with the range of numbers and what they mean according to the different scatter plots and their correlations. So flip over to the next page, and as I'm writing down these pieces, I want you to write them on your page as well. Here's our correlation coefficient scale. As you can see, it goes from -1 all the way over to +1. And within those two numbers, we have a whole range of numbers. -1 describes a perfect negative correlation. 0 is the number that we use to represent no correlation. And then on the other end, we have a perfect positive correlation that's represented with the number 1. but within those are all different ranges of numbers. So we're going to start with negative 0.99 to negative 0.70. That range of numbers describes a scatter plot that's strong and negative. So we would give any strong negative scatter plot or a correlation with that's strong and negative, a number between those two. The next range, negative 0.69 to negative 0.20, are numbers that describe a weak negative correlation. A correlation coefficient between negative 0.19 to 0.19 is used to describe a scatter plot with no correlation. A correlation coefficient with between 0.20 to 0.69 is a correlation coefficient we use to describe a scatter plot that's weak and positive. Lastly, any numbers between the numbers 0.70 to 0.99 are the numbers that we use to describe a correlation coefficient or a scatter plot that's strong and positive. So anytime you're trying to describe a scatter plot, you would use one of these numbers in this range. So let's look below and see if we can estimate the correlation coefficients for the scatter plots below. So let's look at the first one. If we circle up the first scatter plot, we can notice the points are close together. So this scatter plot would be considered strong and positive. So we would have to look up at the top of the page to the different ranges of numbers. And the range of numbers that describe strong positive is 0.70 to 0.99. So we would estimate this correlation coefficient for this scatter plot to be any number in between there. So I'm going to pick 0.80. It could be anything. It could be 0.75. It could be 0.95. It's just getting an idea of how to estimate a correlation coefficient. It can't be 0.50 because that's out of the range for a strong positive scatter plot or correlation. Let's look at the next one. Circle up the dots and we notice they're more spread out. So we would describe this as a weak positive scatter plot. So we'll go up to the top of the page, look at the scale we would use, any number between 0.20 to 0.69. And I would give this scatter plot a 0.55. Any number between those two numbers is fine. You could have named it 0.60 or 0.35. It doesn't matter as long as it's within that scale. Now underneath it, we'll look at the next scatter plot. If you circle up those points, you'll notice they're closer together in a negative direction. So we're going to go up to the top and use any number that describes a strong negative correlation. So that would be a correlation coefficient between the numbers negative 0.70 to negative 0.99. So I'm going to pick negative 0.90. Lastly, we're going to look at this scatter plot. As you circle it up, it's more spread out. So we would describe this as a weak negative correlation. So if you go up to the top of the page, if it's a weak negative correlation, we're going to use any number between negative 0.20 and negative 0.69. It could be any number within there, but I'm going to pick negative 0.60. You could pick negative 0.50. You could put negative 0.3, but you can't pick negative 0.79 because that's out of the range of numbers. Lastly is our final scatter plot. If you circle it up, you'll notice there is no correlation within this scatter plot because the points are in no discernible direction. So that's no correlation. Go up to the top, look at the scale of numbers, and we're going to use any number between negative 0.19 to positive 0.19. So I just give that one a 0 because it's the easiest one to use. So now that we have all the different types of estimations for correlation coefficients, let's try some on our own. So flip over and complete the try these. Enter all your answers on the Edpuzzle for the following multiple choice. Good luck.